As a food scientist, your job is to keep food safe from spoilage organisms and pathogens. Your training has taught you to control microorganisms in food by controlling the food's pH. Various procedures, including heat processing, are needed to make salsas safe for storage. Today, you'll be considering the salsa's pH, or level of acidity. Your biggest worry is Clostridium botulinum. In the lab, we shorten its name to CBOT. If conditions are favorable, these bacteria can multiply and produce deadly toxins.
Oh, baby!
Spicy salsa company Salsa has a pH of between 4.7 and 5.1. This makes it vulnerable to CBOT. The salsa's current level of acidity would be favorable for CBOT spores to come out of their protective state and start growing. Your goal is to create a salsa with a pH less than 4.6, so CBOT won't produce toxins. Even though heat processing is important, cooking the salsa before canning it won't destroy CBOT. During normal salsa processing, the jars of salsa will be vacuum sealed in a boiling water bath, but this won't prevent the growth of toxins. CBOT loves nothing better than a vacuum seal. In fact, CBOT will only grow if oxygen is not present. A sealed jar with a pH above 4.6, sitting at room temperature, is a perfect environment for CBOT to grow. We know that CBOT will not grow at a pH below 4.6. To lower the pH of the salsa, we can add acid. Our goal is to bring the pH below 4.6, but for safety, we will shoot for a pH below 4.2. Which form of acid do you choose to add? Lemon juice or vinegar? Make a new test batch of salsa, 4 liters in size, with all the ingredients we had before. You'll add varying amounts of acidic ingredient to this new batch. Take 1 liter of the new salsa, add 40 milliliters acid, and mix. This is sample A1. For sample A2, take 1 liter of the new salsa and add 80 milliliters acid. Make sure to mix it well. The rest of the new salsa will serve as your control, sample A3, with no added acid. Now that we have 3 experimental samples, 2 acidified samples, and a control, the next step is to test their pH. We will take 2 smaller samples from each of A1, A2, and A3 and test each of these smaller samples 2 times. First, homogenize each sample. Begin with the sample labeled A1 and transfer approximately 100 milliliters into a blender. You will need to repeat this process 2 more times. Blend on high speed until the solution appears to be homogeneous. Transfer the first salsa sample into 2 beakers and label them 1A and 1B. Repeat this process with samples A2 and A3. Repeat this process with samples A2 and A3. Repeat this process with samples 2A and 2B. Repeat this process with samples 3A and 3B. Now you have 2 samples from each experimental version of the product ready to be tested for pH. You will take 2 readings of each sample. Using multiple samples in this way increases the precision of your measurements. Now it's time to measure each sample's pH. You have already calibrated your handheld pH meter to make sure it is reading accurately. To review, see Calibrating the pH meter. Clean off the probe of your pH meter with tap water. Make certain the meter is in measurement mode. Do this by pressing the CalMES button. Make certain MEAS is on the digital screen. Here we go. Place the probe in the first beaker, 1A, and make a gentle stirring motion until the reading on the digital screen stabilizes. Stirring keeps hydrogen ions from accumulating on the bulb and affecting the pH reading. Rinse off your meter and repeat this reading for beaker 1A. Repeat the process, rinsing meter, placing probe in beaker, gently stirring until reading stabilizes. Record the readings in your notebook. Then take 2 readings from the second beaker, 1B, each time rinsing the pH meter, placing the probe in the beaker, stirring until the reading stabilizes, and recording it in your notebook. You will calculate the average pH reading for each sample. Calculate the average pH reading for sample 1A. Calculate the average pH reading for sample 1B. In a lab setting, this process would need to be repeated twice. Now you have taken 2 independent pH measurements, each of which is the average of 2 pH readings for each of your new salsa samples. The 1 liter salsa plus 40 milliliters acid, the 1 liter salsa plus 80 milliliters acid, and the control. Here are your final results. Looking at these pH values, which version of the salsa will be safe from CBOT? Remember, your goal is to be below 4.6, preferably below 4.2, and not to have too much of an acid taste. Consider the 3 samples. Which should you choose? Good decision. The reading for sample A2 is well below the required 4.6, and it is also below 4.2. If the sample we chose had measured above pH 4.2, we wouldn't have had the desired added protection. Now that we've reached our goal of keeping the salsa below pH 4.2, we may decide to run more samples of A2 to perfect our method. Other food science workers will perfect the salsa in other ways. To make sure customers will enjoy the salsa, members of the team will conduct a sensory analysis. Once we have a recipe that people like, at a pH level that protects from CBOT, the test kitchen will develop the heat processing steps to destroy other pathogens and spoilage organisms. Keep in mind that you're never finished testing and analyzing your product. Check the pH of each batch in production. Do all you can to make sure your salsa is both safe and delicious.